Now let us discuss our next chapter, that is meshing. As discussed yesterday, meshing is the most important topic in FEA. Meshing is the discretization of a component into a number of elements of defined size. These elements can be of different types like 2D, 3D or 1D, and of different shapes like tetrahedral and hexahedral in 3D or triads and quads in 2D. In FEA, we divide the geometry into various small number of elements. These elements are connected to each other at points that are called as nodes. Now if you see in the below figure, you can see that we have a CAD part over here which is not meshed initially, and after meshing the elements are created in this figure. Okay. Meshing is a very important part of pre-processing in a FEA software. In Ansys Workbench, we have many tools for creating the mesh. The most important factor about meshing is that what should be an effective size and type for meshing. An effective mesh is the one that requires less time to create the mesh and which gives maximum accuracy. In Ansys Workbench, we can first create the meshing using the default settings whatever we have, and then we can use the tools that are available for creating an effective mesh or for refining the mesh. So if you see in this figure over here, you can see one model which is already meshed using some settings. So here we have used the default mesh settings. So by using the default mesh settings, we have generated the mesh over here. But if you see, in some areas it has created a coarse mesh. So the default mesh that we create will produce a coarse mesh, after which you can use the refinement options or some advanced settings to produce a finer mesh. So if you see this image over here where the meshing looks much more finer. Okay. Now the meshing can be created using the meshing window, which is a standalone system. You can see over here, this is a standalone meshing window which we can add from the component system, and this can also be used for generating the mesh. If you add this as a standalone system, you will only get the geometry and the mesh settings. You will not have the engineering data for it. That means you will have to attach another system, or you will have to take this to another system where this geometry and the meshing can be used, or the meshing can also be created in a mechanical window. If you see, the model cell over here is nothing but the mechanical window, which you will have in any analysis system. You add any analysis system, whether it is structural, thermal, model, you will get the model cell inside that. Okay. Now in Ansys Workbench, we will be studying about two types of mesh settings, that is global mesh settings and the local mesh settings. We will be discussing both the types in the coming sessions. And while we are discussing about these mesh settings, we will also be discussing about some more tools, that is geometry optimization and assembly contacts. So let us start discussing about the graphical user interface involved in the mechanical window. Okay. So let me add one analysis system. I have added one static structural analysis system over here. After that, we will import one geometry. Okay. After importing the geometry, we will now enter into the model cell. As soon as you double click on the model cell, you will enter into the mechanical window, which can be used for generating the meshing. So now here you can see that the model has been imported and we have got the model into the mechanical window. So in the mechanical window, let us understand about the graphical user interface first. So if you see over here, once you open the mechanical window, you will get the toolbar, okay, the title bar over here. Then we have the standard toolbar, we have the main menu bar. This over here is again called as a tree outline. Then we have the details window. We have the status bar over here. We will have the ruler, the graphics area, the view triad. Now here you have something called as viewports drop down, which will help you to add new viewports if you wish to. Then we have the graphics toolbar, by using which you can rotate your model, pan your model, zoom in, zoom out. Then we have the selection toolbar over here, using which you can select whether you want to select the entire body or faces or edges or points. And then we have the contextual toolbar. The contextual toolbar will change, and the options that appear in the contextual toolbar will also change as you click on different options in the outline. For example, if you click on the model in the outline, you will get options according to that. If I click on some other options, for example, now if you see over here, if I am on the model, the contextual toolbar has some other options, some different options. But as soon as I click on the mesh option over here, the contextual toolbar changes. If I click on static structural node, the contextual toolbar will change. So depending on the options you select, the contextual toolbar will change. Okay, now that we've understood the graphical user interface of meshing, now let us understand how to perform a mesh or how to generate a mesh in the mechanical window. So now this is the model that we are supposed to mesh. Now for generating the default mesh, select the mesh node over here in the outline, tree outline, and then you can right click on it and you can say generate mesh, or else you can click over here on the update tab over here in the contextual toolbar. So right click and you can say generate mesh. So when you click on the generate mesh, what happens is we are going to get the default meshing. Now the meshing that you see over here is the result of the default mesh settings that we've got. Okay. Now after this meshing, you can see in the details of mesh, you can come to the statistics option over here and you can see how many nodes and elements have been generated using the default mesh setting. So this is how you will create a default mesh using the default mesh settings. Okay. Now the accuracy of the results, when you are performing the analysis, the accuracy of the results of that analysis depends a lot on the mesh quality of the model. The more the number of elements, the more is the accuracy of the analysis. So if you want to have accurate results, you need to refine the mesh. Okay, but as you are refining the mesh, what happens is the time required for the analysis is also more. So if you want to have accurate results, you will have to refine the mesh. Okay, now we will take an example for this. We will come back to the same model. Now if you see, we have one model on the screen. The material that is applied to this is structural steel. I will click on the static structural node in the tree outline and we will add some supports. Now don't worry about the procedure. We are going to see this procedure when we perform the analysis. I will just quickly perform one analysis. Okay, I have added some supports over here, and after that I am applying a boundary condition and I apply some pressure on this. After that I will select what are the results that I want and then we will solve it. So we will get one result over here. After the results, if you see, because I have asked for the total deformation after applying this pressure, you can see the value of the total deformation. Now according to this analysis, I am getting a deformation of 4.7693 mm because of the pressure applied. Now if I refine the mesh, okay, let us refine the mesh. We will also talk about this refinement option later on in the coming session. Okay, now you can see that the mesh is much more refined over here. Okay, you can see that the mesh is refined and the number of elements and nodes have also increased. Now because of the refining, you will see that the answer has also become much more accurate. Now instead of 4.7, now the result that you are getting is 5.2. if I refine the mesh still further, you will get much more accurate results. Okay, so this is what we are trying to understand in this statement over here, that the accuracy of the results depends on the quality of the mesh. The more the much finer the meshing, the much accurate the answers, but the time taken is also more. Okay, if you see, we have one more example. The same thing is over here. Initially I'm getting some results over here, but if I refine the mesh, the answer also is getting much more accurate. Okay, the same thing we have understood what over here.